So here's the last part of number 5 from the 2014 AB exam, and this is kind of an odd situation. You don't have many definite integrals that look like this that you're ever asked to do, but if you think about how you would find a definite integral using the fundamental theorem of calculus, you would find an antiderivative for what's sitting here, and then you would plug in these limits of integration and take a difference. So what I want to focus on first here is finding an antiderivative for this. So I've dropped the limits of integration momentarily just to try and see if we can determine what an antiderivative for this would be. Now what we have here is we have a function g of x inside f prime. So what we have is we have an outer function, inner function situation. And if we have a situation like that when we're doing an antiderivative or an indefinite integral, we try to let u equal the inner function. And if you let u equal the inner function, I'm going to scroll down here, I'm going to need a little bit more space than I have to work this out. If you let u equal the inner function, you're going to be able to say, alright, this antiderivative, or this indefinite integral, is going to be able to be rewritten as f prime of u going in place of g of x. We would still have this g prime of x there, but then we want to figure out what to replace this dx with. So we would compute the derivative of u with respect to x, and the derivative of g is g prime. What does dx equal? We'll multiply by dx, divide by g prime, and what you're going to be putting in place of dx is du over g prime of x. So we're going to have du over g prime of x. This cancels with that, so that's nice. We needed that to happen. If we rewrite the integral, it's going to be f prime of u with respect to u. Well, what's an antiderivative of f prime? An antiderivative of f prime would be f. So it would be f of u. Technically it's a plus c here because I have indefinite integral written on the page right now, but I'm going to eventually go back and bring the limits of integration back into the mix, so I'm not really going to worry about them. I do want to back substitute, and when I back substitute, I end up with g of x going in place of u. So the antiderivative of what we see here within this integrand is going to be f of g of x, what we have written right here. To finish the definite integral, we would just have to evaluate this from x equals -2 up to x equals 3 and take a difference. So we're going to have f of g of 3 minus f of g of -2. I'm actually going to go back up to the top of the screen here and do it in the side columns because we need to see the table to finish this evaluation. So that bottom line said f of g of x evaluated at 3 and -2. So we're going to have f of g of 3 minus f of g of -2. G of 3 you can get right out of the table. Here's the column for when x is 3. Here's the row for where g of x values are located. So that's going to be f of 1 minus f of what's g of -2. So here's the row for g. The x value of -2 is right here. So we're looking at -1. So what is f of 1? Well, here's the row for f. Here's the x value of 1. So we're looking at 2 minus f of -1. Well, f of -1 is right here, 8. So we used all of these values from out of the table, and the value of our definite integral is -6.